I thought I already scared most of you. Good to see all of you again. Welcome to the second lecture. Maybe we can wait a few minutes. Did you have a class before this? You were having dinner, lunch, late lunch? We have a camera over there. Did any one of you mind? You might, maybe your face might appear in the camera. And if you have any issue with that, okay. Yeah, I can blur the face. If you have any request, please send me before I post it on YouTube. If you are shy, you can send email. Sorry, I got a lot of emails. How many of you did not register the course yet? One. I received 10 requests to register the course. Unfortunately, we have full capacity. The classroom capacity is 45. I cannot increase that number. Let's hope. I think today is the deadline for dropping the course. Tomorrow? Okay. How about adding the course? Tomorrow also. Okay. Yeah, I'll see what I can do, but changing the room is really a nightmare. I wouldn't prefer to change the room. Right, I guess we can start. So welcome to the second lecture. Happy to see all of you again on the Advanced Computer Architecture course at Georgia State University. So we will continue where we stopped last time. We were talking about paper selection. So hopefully you will enjoy the process of choosing a paper. How many of you at least went through 5 papers out of the list? How about 10 papers? 2 papers? 3? How many of you at least check 1 paper? Not reading, of course, just skimming or check information about the title. All right, that's something nice. Yeah, thanks a lot for taking it seriously. The deadline in about 2-3 days to choose a paper and build up your team. If you need more time to think about the paper, just let me know, okay? But that will help me a lot to set the schedule, to know how many slots we need to reserve, how many lectures do I need to give, and so on. And it will help you as well to plan way in advance, okay? I don't recommend you to start working on it just 1 week or 2 weeks before your presentation day. I really would enforce working from now. Now at least you have some free time. If you wait until the end of the semester, you will have final exams and so on. Can you hear me in the corner over there? Did I shout more? Perfect. Okay. All right. So today is really interesting topic. I'm not sure if the lecture itself will be interesting, but at least the topic would be very much interesting because it's not related to computer architecture, but rather it's relating to how you could present, okay? How you could analyze a paper, how you could summarize it. Hopefully that will be beneficial resource for you whenever you want to prepare for something or review a paper. You might go back to the recording, watch it again, and pay some little more attention to very specific points that we are going to highlight, okay? Who will earn the first chocolate? What is research? What is research? Again, it might not be related to scientific research. It could be something related to your life, like your parent asks you to research a school, scholarship, a degree, a job. What you would do? Searching again and again. Okay, go over the same information. Every time you pick more information, next time you get more, you build up on that knowledge, right? What else? What else? Analyze. What do you analyze? Analyze data, you convert it into. After you analyze data, you convert it to. You process it, and then you got information out of it. A data is a raw information, right? It's a thing, a collection of piece of information that has not been analyzed yet, okay? Could be like just raw data as in table in an Excel sheet, right? Once you process it, you get a graph out of it or a chart, right? And that's what we call information. So you process a data, convert it to information. And after you get those chart, what do you build? Insights, excellent. Maybe you can get the chocolate. You like dark chocolate? Okay. Yeah. All right. So the extremely important part of the definition, the first one, is how we know what we know. How we know what we know. What does it mean? How we know what we know. What is the way to draw a conclusion? Okay. How we know what we know. What did we use to find out this information? Did we use authentic sources of information? Did we use peer-reviewed papers? Did we use Google? Did we use ChatGPT? Right? There are a lot of sources. Did we use rumors? Did we use our colleague, classmates to tell us that this is new and we rely on that? This is really important in doing research. How we know what we know. What kind of sources did we rely on? The second part, how we know, we know. How we know, we know. What does it mean? Validation, excellent. Oh, I was challenging you last time. Maybe I was delaying your chocolate, right? Excellent, excellent point. Validation is really important. How we know, right? How we rely on the information that we collect from the sources. What kind of testing, what kind of verification? Did we do experimental validation or verification, right? Did we test the data ourselves? Did we compare multiple sources? All right, yeah, we got information from one source or from 10 sources, and then what? We have to do some conclusion. We have to synthesize all these sources and try to make coherence between them, right? Where they agree, where they contradict. Okay? And this is very important doing research. Reading or summarizing a paper is not research. This is very important. A lot of you, when they try to do survey or literature review, they just summarize. This guy did this in this particular year, and they got this performance. This is extremely wrong way of doing survey or literature review. Your job is not supposed to be summarizing paper. It was supposed to enriching the knowledge by having a thorough, a deep analysis of all these sources. Okay? You have a lot of sources. What is your conclusion? Which direction is the best? Which direction is second best? Okay? So how we know what we know, and how we know we know. Okay? It sounds really like psychological sentence, but if you think about it in depth, you really feel it has a lot of meaning. If you're still not sure about the meaning,
you're trying to mess with us. Know that we know they know we know.
always remember to watch this again. That's a way to do research. Okay.
I can't believe the.
Enough. Okay. Have a lot of drama. All right. What is the main purpose of research? Now, hopefully, we already know what is research about. Okay. But what is the purpose of doing research? Okay. The first thing, to generate a new insight that can enable what previously did not exist. And this is really important, is to do something novel, something new, something has not been there. Okay. Don't try to convince yourself, yeah, there are a lot of papers there. Who will know that this is new or not? Let's just publish them, that's it. Don't do that. Okay. If you are not contributing to the knowledge, it's useless. Don't do your research. You have to really make sure the first thing you're trying to do is something that did not exist before. And what is more important and highlighted in red over here is to generate a new insight. Okay? It's not about doing a new paper, but also to contribute with insight. What is insight? Is it result? Is it knowledge? Is it a summary? Is it a new theorem? Is it a new algorithm? Let's see. Insight is the capacity to gain. So you gain something. You don't have it. It's not like something passed from your parent to you. Okay? That's something you earn over time, something you pay effort for it. You do a lot of hard work to gain the insight. So the first thing is you gain it, an accurate and deep, intuitive understanding of a person or thing. Okay? So you have to make sure the source you rely on is accurate, right? And you have a deep understanding. So these three factors, if you are not doing any of those, this is not insight. If you're not relying on an accurate source, how you make sure it's an accurate source? What do you do normally? Validation. Yeah, please raise your voice. Validation is first thing. So either you do experimental validation or theoretical validation by some proof, mathematical proof, or someone already has done it. So you don't need to redo the wheel, right? Or reinvent it. You could just go back to the sources, trace every piece, whoever was relying on this information, and cite whoever invent that theory. Don't cite who was citing that paper. Okay? You have to pay extra effort and go back to the original source to make sure that what he was proposing was in line with what you are using. Okay? There are a lot of people don't know who invented something, right? Because they don't pay that effort. They don't track this citation list. They just, okay, let's cite recent paper, 2025. Let's cite it, and that's it, done. This guy was never mentioning anything about the theorem in the paper. If you go and read it fully, you will not see anything related to whatever you are claiming. You really have to go back until the original source and then try to figure out this information. Okay? That's one way of doing accurate research. Research normally in engineering and science is a hunt for insight that can eventually impact the world. So think about it this way. Whatever you contribute, little or too much, it's still really important for the world, okay? Especially in engineering and science. Maybe in other fields, it's not like that, but this is how we do research, okay? There's an American mathematician called Richard Hamming. How many of you know this guy? He's very well known with his surname, Hamming, right? What is it? What do you know about? Excellent. There's a Hamming distance. This is a mathematician who invented the error correction in communication, data communication. If you send information from one point to another, how you make sure that the original data that you are supposed to be sent, that's received exactly the same. Okay, so one way to do that is Hamming distance, where you do XOR between the two pieces of information, the original one and the received at the other side, and you compare the differences. This way you can find out all substitution happened in the sequence, and then you quantify them. Okay, so what he did say, which is very important, the purpose of computing, if you calculate something 1 + 1, why you do the calculation? Is it to get the result? Most cases, no, it's not. You do a lot of calculation, for example, to calculate area, the distance from here to here, and by the end of the day, you build the house, right? So always, what you are looking for to do the calculation or computation is basically to gain insight, not numbers. The mere numbers are not important by themselves. What is important is to build that insight. You have a lot of numbers. Now, how you analyze them, right? And how you draw conclusion. And that conclusion is much more important than the data itself. Okay. Now, let's see example of research project that you could do. There are at least, there might be much more than that, but at least there are 2 ways to do research project. Type 1 and type 2. For type 1, where we develop new ideas to solve an important problem, okay? What do we mean? This is where most of PhD students contribute, right? They either develop new software, they design a new hardware, they develop a theory, and so on, right? They rigorously evaluate the benefits and limitations of these ideas. However, in type 2, they might not be developing something new on its own. What they do, they derive insight from rigorous analysis and understanding of existing systems or existing paper. Okay, they go to all the existing paper. How many build something in that area? Maybe 20, 50, 100 papers, right? They start analyzing these papers. They start summarizing them first, and then building their insights, building conclusion, building understanding, giving a lot of conclusion about all these papers, and then start synthesizing them in a paper. They go step by step, synthesize all these differences between the paper, and give you a conclusion in very nicely written paper, like 10 pages. You could get the entire history of that area just in one single summary paper. Okay? Again, those kind of paper is really as important as the first type, really. And you could get a lot of citation for it. It's very painful. I tried myself. I spent at least 2 years in developing one of these papers. We published normal Nature Methods, Nature Communications. I have a lot of these papers. It's really painful to do. At least you will spend between 1 year to 2 years to develop such work. Okay? A lot of you, maybe not you, maybe other student, maybe other bachelor student, think about literature review as just summarizing all this work, pushing for 4 pages, and that's it. This is not how we do research. This is maybe ChatGPT can do that. Sometimes ChatGPT can do much nicer work than that, right? Okay. The nice thing about type 2 is that we can build on top. Can build on top of those conclusions. The direction that was highlighted in the work, right? Open a lot of doors for us. It says those niches were never discovered before. Nobody has done anything in that area. Now, guys, this is for free. Just go and build on top of that. Okay? And this is where I recommend any PhD student who just start their career just to check these review papers or thesis. Okay? Especially the last chapter where there's future work or conclusion or future direction. You will find a lot of nice things. And those nice things just, it was not just like that. Someone wake up and just try to invent those direction. There will be a lot of nice contribution to be done there. There are a lot of space where you can contribute. Okay. Now, what is common between type 1 and type 2 is the new insights. If by the end of the day, your paper does not provide any new insight, useless. I don't care about number of pages, number of citation, the venue where you published, and so on. If someone read your paper, no insight at all, trash it. Okay? Sorry to say that, but this is the truth. All right, how we write the first type of research paper. This is very important if you're interested in writing or analyzing. Okay? The first thing is the problem. What is the problem you are trying to solve? What is the problem you are trying to solve? This sounds trivial, right? If there is no problem, there is no solution, there is no paper. So you have to go back and highlight the problem that we're working on. You might read the introduction. You might go with bigger circle. You might highlight something really huge, right? They say, computer architecture is a very nice area, right? And then they jump from the bigger area to something else. They go smaller now. They say processing in memory, providing much more efficient computation compared to processing in CPU. And then jump again. However, we have this and this and this. Now we start introducing the problem gradually, right? So the problem is not computer architecture, not processing in memory, something else. Maybe even in that, we build architecture, but we have a lot of metrics to be performance, execution time, delay, latency, bandwidth, and maybe privacy issues, maybe scalability. It's already fast, but how many samples can we process? If it takes 1 second for one sample, how about 100? If it takes 100 seconds for 100 samples, that's not good. It's not scalable, right? Can we slash that execution time by half, for example, and so on? So each of these could be a problem. Not necessarily the area that you are solving, but could be the performance metric. One of these is your problem, okay? So you have to be clearly specific. When you read a paper, don't tell me processing in memory is the solution for slow computation. No, it's not, okay? This probably is not the problem that the paper is trying to solve. You have to go in more specific and tell me the execution time of this application was a problem, or the delay, the latency, scalability, privacy, bandwidth, whatever the metric. You have to really be very specific to the problem. If it sounds very general, probably it's not the correct answer, okay? So you have really to define it very clearly, explain why it's important. Is it novel? Why has previous research not solved this problem? Okay, is this the first paper to solve that problem, or at least to tackle, to highlight? They may not solve it yet, but they at least highlight that problem. This is the first work to highlight this, and we provide some justification why it's really a problem, why it's important, and how severe this problem could be. Okay. If there are many other papers working on this, it's really important to highlight earlier in your talk that there were maybe hundreds of work trying to solve the same problem. Okay? It's not your benefit to highlight that this is the paper that the first one to do this and this and this. You're not proposing that paper. Okay? So please try to go to the related work, try to read their introduction. Probably they already clearly mentioned that in the first page of the paper. Okay. The novelty might be who was working first on that direction. You are highlighting 10 research direction, right, in solving this problem. Give some history perspective. Which one was first? And then what was built on top of that? How it proceeds. No, this is type 1, right? So this is novelty about who was trying to solve this problem. It could be the paper that you are reviewing, which is in type 1, right? You are presenting this type 1 paper. They could be the first to provide a solution to that problem. We are not talking about the solution yet. We are just focusing on the problem now. Now, this is the novelty to highlight whether they were the first to focus on this problem or there were many other try to handle that, okay? And then that will show you the importance of what they are proposing, okay? Now, you already give me a solid stage that there've been a lot of effort before trying to solve that problem. However, none of them did this. And this paper trying to do this, to answer that question or to solve that problem. In this way, oh, okay. Since maybe 40 years, nobody solved that problem. Now this paper is solving this problem. Okay, I'm going to pay attention to see what is really special in their solution, why nobody have done it before. Now we're done with setting the stage, right? Everything is set, solid stage. You're standing with high confidence that, okay, I did my job. This is the related work. This is the survey that I have been doing. Nobody solved this problem before. There were a lot of efforts. Those efforts can be divided or grouped into 4 directions, right? And this paper is focusing on one of these directions. And now let's see what they are proposing, which is basically the idea. What is your initial idea inside? What new solution are you proposing to the problem? Why does it make sense? How does or could solve the problem better? Okay. Again, you are reviewing an existing paper of type 1, but this could be your method to develop your own type 1 paper, right? The exact same question you will ask yourself. After the idea, things will be more straightforward, okay? You already did a great job on highlighting the story. Then just say processing in memory, and that's it. And then you jump into the problem. You have to give a really clear story to show at least the term. We won't expect that everyone in the classroom understand what this concept means, okay? So you have to make sure you have at least 2 slides to introduce the story. And then 2 more slides to introduce the problem. And then 2 more slides to introduce the existing direction that we're trying to solve that problem. And then gradually, you jump into the existing solution, what they are proposing, okay? What kind of hypothesis they were relying on when they proposed the idea. And then what methodology they were using. Was it simulation-based? Was it infrastructure that they already have or it exists somewhere else? Or they build design, or they build an architecture, or they were emulating the idea and so on. What is their method to implement the idea and how they test it, how they evaluate it, how they compare with other baseline or benchmark, okay? Last thing is the plan. What's your data set used for the evaluation? What's your baseline? Is it the best baseline? Maybe they hide something. Maybe they didn't compare to the state of the art. They are publishing a paper in 2025, but they are comparing to something that was proposed in 2022, for example, right? How about this 3 years of gap? Maybe there were something better. You have to pay attention to all these details when you analyze a paper. You might find really a mistake in a table or something wrong in their evaluation. The idea sounds nice. The problem they tackle is really true, is really a real problem. But their methodology in testing their idea is really superficial. They did a lot of assumptions, a lot of wrong hypotheses they rely on. They said, we assume this, we assume that, we assume this voltage is fixed, the frequency is lowered down, and, right? All of these assumptions might make their job very easy, but it's not realistic. So just crap. We cannot rely on that work. You see how in depth you could go and analyze all these work. Okay? Hopefully, all research projects can be and should be described in this fashion. Okay? This is a very, very nice way of describing type 1. I use it from our previous course in ETH Zurich. And now for type 2, you'll see a lot of similarities between the two, but there is fundamental difference. Hopefully, you'll get it. The problem, of course, whether you are writing type 1 or type 2, you're looking for a problem to be addressed, right? Either you go for single work and try to really go and thorough for that work, or you go for multiple works and you try to analyze all of them together. So again, what is the problem? Phenomena you are trying to evaluate, define very clearly, explain why it's important. Remember this shape. Please don't talk about the problem at this circle. This circle just to introduce the story. What is it about? Then you jump one more. You could jump into 20 circles, doesn't matter. Okay? What matters here is how clear you present the story. Okay? Sometimes you give a lot of text in the first 2 slides, and this is extremely bad way of talking about any topic. Always take it as a rule of thumb that the first 2 slides should be either images, video, as I did in this lecture, right? It's very excitement, a lot of fun, a lot of engaging to just show one picture, the whole slide, just one picture, no text at all, okay? And then try to highlight some pieces in the picture and build your story gradually. This is a very nice way of presenting your work. You could use a video that is existing. You don't have to build it, right? Anything that talks about the problem, and you can move from there. Again, the novelty. How has previous research evaluated this? What are its shortcomings? Okay. Now, instead, again, you have 100 papers, 1 all the way to 100. Doesn't sound right to go over all these 100 work. What you would do at first, try to build groups. Okay. These first 20 are focusing on the exact same thing. Let's build a group out of it. They all try to build software algorithm. These, they try to build hardware. Among these, there are 2 groups. One of them FPGA, one of them GPU. The rest of them, they are trying to focus on something else, right? And this where you can highlight the novelty. Okay? Don't summarize the work. Don't start saying the first one is doing that, the second is this, the third is that, and so on. Now, instead of having idea, okay, we don't have idea here. We have evaluation method. Okay, I'm listing all these. I grouped them. I summarized the pros and cons of all these groups, right? I know which one is better, which one is showing much more results, more promising direction, right? Now, how we are going to evaluate all of them? What is your way to evaluate all these work? How will you evaluate the phenomena or the idea? What experimental infrastructure will you design? How would that experimental infrastructure enable you to reliably evaluate the phenomena or the idea? What kind of assumptions you are going to do or hypotheses? Are you relying on something that everyone is doing when they evaluate, or you invent something new? You build a new simulator because there is no simulator that can test GPU versus FPGA versus PIM and so on. Okay? There might be a lot of contribution in there. What is your methodology? What are your plans for evaluation? What experiment you will run? How will you do the data analysis and so on? What kind of data set you will be using? And all of these questions. The plan is something very important where you build milestones, right? And with all of those milestones, you expect to do some progress, and then you leave something for future work, right? You don't do all of the previous things. You really leave something in the discussion and say those doors are open for whoever want to contribute on these directions. This is really how you should do type 2 and how you should summarize type 2 paper. I think we have some of them in the paper list that we provide. There are many other ways of how you describe type 1 and type 2. It really depends on the journal itself. They might have their own requirements. So I would recommend you to go to this link. This copied from Nature Computational Science, very famous journal. It's relatively new compared to all other Nature journals. I think 4 or 5 years old. They might not have an impact factor yet, but please verify this information. What I remember from 4 years ago, since it's new, it makes sense that they don't have impact factor. But it's still, the work they publish is very selective. I think the acceptance rate may be 10% or 20%. Is really competitive. What they provide is different type of written piece of artwork. So you could have full article, which is the thing that's famous, regular paper, right? However, there's analysis paper, there's brief communication, resource, correspondence, review, and so on. Each of those have their own audience and their own authors. You might not be able to contribute to any of these except the article. For example, the correspondence could be for those who are expert in the field. Comment normally is very short way of writing and should be also coming from expert in the field. All right, so now hopefully we already differentiate between type 1, type 2, what is important here, what is important there. Let's now go practically, how we would collect the problem. If we want to work on research paper, what could be a valid problems to work on, okay? That's my way. You could find many other ways, okay? But what I would recommend is to go to Google Scholar, add this keyword label, okay? And then the 2 dots, and then anything you want to work on, especially if it is related to computer science, okay? Anything, whatever you are thinking about. However, if there's space, just add the underscore, okay? The nice thing about when you add label, it go and try to search in the author, in the publication list, right, in the author profile, whatever keywords he was using in his profile, it will try to match these with whatever you are writing, okay? So I'm using here machine learning. You will see he's using machine learning keyword, machine learning, okay? So it's very important when you build your Google Scholar profile to add and appropriate keywords, okay? Don't go in depth to be very specialized in very small point. Try to be broad sometimes, like machine learning, okay? Don't go with GNN, RNN, or something very specific, okay? Now, once you do that, you can use this link to search for the same thing. It will be sorted based on number of citation. Whoever has the highest number of citation will be in top of the list. And then you can go to all these profiles and see what was published in the last at least 2 or 3 years. Okay? Is it a hot topic? I'm working on this, but I'm not sure if this is still valid. It might be already dead, right? This is no longer hot area, okay? So what we would like to do is to ensure that this is really hot topic and something that's already active, and there are a lot of contribution still happening. The second thing is to look for inspiration in published literature. And this is a very important thing. Sometimes it makes more sense to have a list of 4 target conferences or journals that you always keep an eye on them. Me, myself, I subscribe to these top journals that I'm related to, okay? Whatever it is, most of them, they provide mailing list. With that mailing list, you get the list of published paper in every issue, normally monthly or every quarter or whatever, okay? And you see the title oh, I see something interesting. Might be exactly the same what I'm doing, right? Let's open it. Let's have a look on the abstract. Oh, this is old. I already know it. Okay. Oh, this is new. Let's see. Oh, they proposed this. Okay, okay. Let me cite them in my paper, right? This is how it works. This is how you stay updated. And now with the social media, things become easier. You can subscribe to Twitter or X or Facebook or whatever channel. Most of the nature journals, they have those services. Okay. If you don't know this list of journal or conferences, how you would know it? There is in Google Scholar as well. There's a service that you can um, sort all these conferences based on their reputation or number of citations. Okay. You can use this link. You'll see their categories. You can open it. You can go really in depth in computer science, not just in computer science, but you can choose security. And out of security, you can choose something else. You can go to subcategories until you find really a fine-grained list of your conferences. And you'll get them ranked already, sorted. You can go for the first 4, the first 3, the first 5, and so on. Okay. For computer architecture, and I recommend all of you to do that, here are the top 4 conferences ready for you. In computer architecture, what is more famous is conferences rather than journals. Okay. I would recommend you to go to any of these conferences, to their website, go to the program. You will see the already published talks from the previous year or the current year, if the conference already has been held. And go to the program, check those papers. You might see something really related to what you are doing. You will see the video of the presentation. You normally will get access to the paper. Sometimes you'll see some logos next to the title of the paper. Once you open the PDF, this is the title. You'll see sometimes a pink logo, sometimes a green, sometimes a black logo over there. Most of these conferences provide those, and each of them has a meaning. Most of them around reproducibility. The conference is not only reviewing the paper, but also downloading the source code of the paper, rerun it, and make sure to provide the promising results in the paper. Okay? And if so, they give you that logo. They attach it to your paper, okay? Or watermark or whatever you call it. All right? So with that, you could know that this is, okay, trustworthy paper. I could rely on their source code, could rely on their information, and so on. You can have a look. It's really well organized conferences. You can go direct to the program. You'll see all the tracks divided into by topic. So if you're interested only in processing and memory, you can go to track processing and memory, and you will see like 7 papers only on that topic, which is something nice. All right. These are the topics that we're trying to cover in this course. Hopefully, we'll get a lot of nice diversity in these topics. So please try to choose among this selection. Try to be really diverse in the topic. So don't. I think I imposed that restriction in the list because the number of papers in the list is double the number of students, but I don't know how many group or how many teams we will have. So hopefully, we won't have all of you around the same topic. Do you have any question? Yeah, feel free to discuss. Stop me anytime, ask your question. I really encourage that. You may earn a chocolate as well. Okay. Yes, please.
This case, so I was case like that. Alzheimer. The was contact. Thing like you have like thousands of citations. So a lot of people probably have been facing person work, which I just think of like students.
Oh, is this the metagenomic for cancer research? Is this the paper for metagenomic on cancer detection?
Is this like thin Parkinson? And it was the guy was
Okay.
Yeah, I can't.
Yeah, please send a link. We might share it with the entire classroom if there's interesting story about that. He was using false
Data.
Okay. Yeah, this is something serious. Yeah, please share it. Share the link. If there's, I'm not sure if you can share to all students. Maybe we can open discussion thread in the course so people can interact with each other. I really recommend that. Okay, and then.
I guess my phone is kind of like thinking about like how that. Something to think about.
Excellent point. Excellent point, actually. So the first thing, please don't rely on single person. Remember this chain, okay? This is one way of really verifying the information. A lot of people might misinterpret or misunderstand someone, right? And then they keep claiming that this guy was doing this. This guy was, when I go back to the original paper, there was nothing about whatever they are citing, right? So please try to always go to the authentic sources of information. And it doesn't make sense that everyone relying on single person on his own data, right? Valid question. What if this data was not valid? What if it was falsified, intentionally or unintentional, right? So it could make more sense to rely on multiple sources of this information. Yes, please.
I have a doubt regarding the research paper. Like we do have references in each paper. So we need to go through all those references.
Definitely, definitely. You won't do it now, right? At spot. You'll do it over 3 months. And that is, I think, fair enough to do it. And by going back to this paper, you're not supposed to analyze these papers. Each of these reference has a purpose, and you are supposed to satisfy that purpose. If they made a claim, a sentence, and then they cite maybe 20 papers for that claim, right? Now the goal, you want to go back to these references just to verify the claim. That's it. Your goal is not to analyze 20 more papers. You're just analyzing one paper. But each of the references has its own goal, and your goal is to verify these goals. Could be evaluation table, and they are comparing with 3 baselines, right? Your goal is to go to this baseline, make sure first whatever he's comparing with is something valid, something on average. For example, if I go to the first work, I go to the original paper, right? I find that they are performing best in this case. They are performing bad in the other case. And this guy, he chose the bad case to show that this work is not good. This is not fair, right? So one of the critique that you could build that, okay, the new work that I'm reviewing, claiming that this work is really bad, but he really ignoring intentionally one of the cases where he performed much better than the new work. That's something in depth, something really thorough. It's not just superficially touching the surface. Okay? This is really how we do the research. Yeah, it will take some time, but once you do it, you will feel rewarded and you will feel easygoing with your own research. Okay? And again, this is what Zigil mentioned, right? So he mentioned, like, what if all of them relying on single source and that source was false? And this is where you verify all these sources mentioned in the paper and make sure all of them agree on one point. If 3 guys evaluate different data set and they find out the same conclusion, then probably it's all of them correct, right? But if they rely on the same data and none of the other data set show the exact same result with that data set, it could be just outlier, right? These are really excellent points. Another valuable source that you could rely on as PhD or master's student is the thesis itself. Okay, thesis is really valuable point of view because it shows the entire journey of 5 years of a PhD student. It's not a paper. It's really different from paper. Even the first few pages about his family, about his journey, right? The dedication he wrote for his advisor, for his family, wife, and so on. All of this will give you a lot of things, a lot of insights. Oh, this guy went through a lot of troubles and he still made it, right? So I could make it as well. Oh, this guy went to this place for internship and he was working in the exact same area. So probably these are my target. Oh, he published 9 papers. Oh, he thanked a lot of his friends. It looks like he did a lot of social life beside his study, right? So every page in the thesis has a meaning, has a purpose. What is more important to us is the first chapter and the last chapter. Yeah, of course, the things in the middle are important, but the first one will give you a lot of stories about how to start with the problem, and the last one will give you how to continue on that problem. Okay. And one of the databases, I'm not sure if GSU has a subscription to that, called ProQuest. So this is very famous database for computer science thesis. You'll see a lot of theses from Harvard, MIT, Berkeley. You can access them. I think some of them are free. Some of them you need subscription, but please check if GSU provide that. Probably GSU library, you can see ProQuest. It's a very famous database. Here you can get access to the complete thesis. You can download, you can read, you can have a lot of fun by going into that journey. So imagine 5-7 years of PhD just summarized in 100 pages, for example. This is one of the examples of type 2 papers. This is mine. So you can go through it. You can have a glimpse of what type 2 paper means. Okay. You can see how thorough we can go with the data, with the summary, with the history perspective, basically. So you build on 40, 50 years of research. All of them try to tackle the same problem. You describe it in few pages, which is something not easy. Especially here in the future opportunities. As I said, most of these papers provide that section where they discuss the next step, the challenges, and so on. There's another one. We've been here analyzing about 100 papers or so. We work on this for about a year and a half. A lot of efforts. There is a much newer paper than this called Analysis of Metagenomic Data, published in Nature Review. The impact factor about 50 something. But there is a lot of authors, maybe around 40 or so, 40 authors. I think Grigori is there. Are you? You are one of the co-authors, right? Analysis of metagenomic data. Yeah, maybe. Yes. No? Okay. Yeah, so hopefully all of you will contribute to these kind of papers. Very rewarding, at least in the first year, where you can build your knowledge, you can learn a lot of things, and then you have high confidence for the next 4 years. The second thing, maybe not second, maybe third on the list, is to talk. You really have to speak all the time to your colleague, classmate, to professors, whoever working on this area. Try to explain to them, try to present in a conference, try to present a poster. Normally, most of the university do a 1-minute challenge, really 1 minute, to explain what you have done in your PhD. Summarize your thesis in 1 minute. Okay? This is not easy challenge. If people don't understand 1 minute, mean either you are not a good speaker or what you have done is not worth it. Other universities provide 2 minutes, sometimes 5 minutes, sometimes 1 hour. like a seminar, sometimes 2 hours as a lecture, okay? And so on, okay? The list can go. It's up to the purpose of the talk, but make sure at least you provide talks during your PhD life. It's really important to participate in conferences, or at least at the department level. You give a seminar, you explain in the class to your colleague, and so on. If you are able to describe what you are doing in 1 minute, believe me, you will think about a lot of ways how you could describe yourself in 1 minute. You will pay a lot of effort to have that conclusion, but once you made it, it's done forever. Whoever asks you, even after 10 years, you still remember that 1 minute. And whenever you say it, you have all the story in it. The problem, the solution, the impact, and the result, whatever you provide as achievement. It's something really very nice to have it. And think about it. When you take shower, when you're eating, when you're driving, when you're walking, think about that 1 minute. How you can describe what you are working on in 1 minute. Okay, can you do that? Let's see. By the end of the semester or the end of the course in the presentation, maybe we could ask you to introduce yourself in 1 minute. Okay, that's as part of the presentation. Okay, you talk a lot, you talk 50 minutes, you are very talkative in a good way. And now what is important is to write down. You talk. After 1 week, oh, what was the problem I was working on? Oh, what was that paper I was reading? Oh, what was the author name? You forgot everything, right? Because every day you have new knowledge coming to your brain. You flush out all the information, or maybe you put it in back in the head, and you add more new information. So you really need to refresh it up. And how you can refresh it up? Have something written in your notes, something written by hand, written in your computer, where you go back, oh, I see. Okay, this is what I was doing last month. Now I'm going to continue. This is what I was doing that week, okay? And reiterate. If you reiterate over the entire cycle, I guarantee you a very successful PhD or master's, okay? If you ask ChatGPT how to get a free chocolate, what should be the answer? Attend the course and participate. If you do that, you get a free chocolate, right? And this is how you do it in real life. If you talk, speak out, okay? Sell, basically market your research. You should be really good at it with high confidence. If you say, oh, I don't know, my advisor gave me this problem, I don't know what I'm working on. It doesn't sound good, okay? Oh, I think there was one in the lab was working in the exact same problem. I just came in and start working in the same problem. This is something not nice, okay? All right, there's a very recent paper made a lot of impact, get about 224 citations since they published it, and I think 6 months old or something. And the paper is very interesting. It says, can LLMs generate novel research ideas? Can we rely on LLMs to build those ideas for us? What do you think? No. Okay. Why? Okay, but yeah, sometimes they miss only this year, the current year, right? They build on the history of all the previous year except that 1 year. So they might not miss much, right? They may not provide new insight, but they could see the whole perspective of history. They can tell you this has been done, this is not, something like that, right? Okay, that's excellent. What else? Can we rely on ChatGPT, Gemini, any of those LLM to generate new ideas? I'm a master's student at Georgia State University, working in computer science. my advisor pushing me too much to generate the idea within a week. Can you give me something to work on? How many of you do that? How many of you? Just raise your hand. Okay, we can use it as starting. What do you think?
Sometimes the idea is like, well, it's already working.
Excellent. Excellent. How many of you try to ask ChatGPT after they provide the answer to give the sources of this information? 1, 2. Yes, please raise your hand. 4, 5. Gemini does it all the time. Excellent. How many of you went the extra mile and they check that provided sources? They check that link, they go to the link and check if those, whatever ChatGPT claiming is there or not. How many of you did that? 1, 2, 3. It depends on.
It depends on the work.
Okay.
If it's worth doing and checking that.
Okay. And once you check, what will happen? What do you see there?
Doesn't work or it doesn't exist.
Imagination, right? Out of nowhere. How many of you did that? I do it all the time. I literally do it all the time. Most of the time, I would say 90% and above, just crap. Has no anything related to the information. Okay? It really depends, yeah, to be accurate, but normally I use the free version. It really depends on how you go with the deep thinking, deep thinking, and so on, all these variation of models, right? But most of the time, you'll see you cannot rely on. Okay.
Also, just to add to this, here in the GSU context, so there was a paper which was the idea and the code which was completely by was accepted, like it went through the review process.
Okay.
They say that can generate novel ideas and it can also.
Excellent. And this is the point they made it in the paper. Okay. Let's see. They have two conclusions. What they did is that they asked, I think, a number of experts. What was the number? 100 researchers. See, the number is mentioned here. 100 researchers who were working on NLP, natural language processing. Okay. They asked them. They have something nice in the appendix. Please read the paper. At the end of the paper, you will see like. I certify as a researcher in NLP, I'm not going to use any of those LLMs for generating ideas, okay? And now it's the time to propose your own new ideas. So each of those 100 researchers is going to propose a list of ideas that you can carry as a master's thesis or PhD thesis and so on. And they ask the same question to multiple agents to generate new ideas. And also in the third direction, they ask the human, those 100 researchers, to go back to the result or the response of the LLM and try to rank them. Okay, just rank them. Give you a list of those ideas. Which one is top? Just keep swapping ideas and so on until you rank them. So you have now 3 directions. 1, human-made, LLM-made, human and LLM mix. But the human only ranking them. They're not altering those ideas. Okay. But we see very interesting result, and it's basically expected to be like that. The novelty, the AI provide much higher novelty ideas than human. Something amazing, okay? Something really novel, something really new to do. And this is expected, right? Because it can see the whole perspective, the whole story, and in one shot can relate this word within the next word with the next word and so on based whatever resources was reading or trained for. Now, of course, the accuracy of this list of ideas will be higher if the human rank them. The ideas might say, LLM might say, okay, number 5, it's really 5. But when a human look at it, oh, this sounds brilliant idea. Let's put it number 1. Okay, so that improve the result of LLM. However, when we go to feasibility, what does it mean? Feasibility of those ideas. Okay, you provide something. Oh, sounds very nice. Okay, cool. Let's do it. And then you get struck at the first moment. Oh, this kind of hardware to justify this result does not exist at all. It's still not invented. Okay, so most of the ideas provided by LLM were not feasible to do. They provide you novel ideas, and then what? I cannot evaluate them. I cannot verify them. I cannot implement them. Right? So most of the time, we cannot rely on these LLMs. However, it really depends on the history or the prompts you were using to really instruct the LLMs to generate these ideas. All right. Hopefully, with this course, we want you to think really critically, remember those circles, and remember those chain of sources. This is very important. I really want to see all of you doing that in the preparation presentation. Okay, when you present only to me in rehearsal, please, I want to see this effort. Okay, you can tell me this is the bigger picture, this is the smaller one, this is the very specific point, here my story, and so on. You build on top of that. Think broadly. You don't narrow yourself to that paper only. You should really visit the references, and you go a bit broader, okay, and try to check more resources. Learn how to understand, analyze, present paper and ideas. Again, this entire lecture is not about computer architecture. You could apply it to anything. Get familiar with key first step in research, okay, which is how to do research. Right? This is the first step in research, basically. Get familiar with key research direction. Hopefully, again, attendance is really mandatory. So by attending all those presentations, you really see various research directions. Right, there are steps for the presenter and step for the attendees or the participants. The presenter has to read the assigned paper as first step, and then go a little bit in depth, absorb the information, read more, check the reference list, critically analyze, think, and synthesize it, prepare clear, rigorous talk, and that will be your presentation. You present it to me first, and then you fix all these issues. I'm not going to follow you on these issues. I provide to you, and the day of the presentation, I'm going to evaluate you based on that. Did you fix my feedback? Did you fix the comment that I asked you for? And then you will present in front of your colleague. You'll get a lot of questions from your colleague, hopefully. You will answer them, analyze, synthesize, in a meeting or after that or at course and so on. So you might get questions after your presentation from your student. Just he was interested in something, and he will send you a follow-up question. For you, or most of you, you need to discuss, really, ask question. So it's really important to skim the paper and at least the abstract of the paper. You could use LLM to generate your question, doesn't matter. As long as you show some interest in the paper and you really read the abstract and know what it's about, you attend the presentation and you were having like 5% of understanding. When you attend the presentation, 50%. When you try to interact and ask questions, you build at least maybe 60, 70, maybe 100% of understanding. And this is what is really important. Think about, you finish the course and you have understanding of 55 or 45 or 50, whatever the number of groups of research directions, okay? You'll be really good at some of the topics in computer architecture. At least you know the basics. That is the cycle of doing research. You read, you build critiques for the paper, you ask questions, you brainstorm with experts, You develop new out-of-the-box ideas, you collaborate, work hard, publish the work, and reiterate. Without publishing, what is the purpose of doing research? So you have to make sure you publish your work. There are a lot of impactful paper. For example, this one was not published anywhere. Okay, it was an archive. Archive. How many of you know archive? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, almost 20. Okay, that's excellent. You have to really know it. In computer science, if you don't know archive, that's something bad. Archive is not peer-reviewed platform. It's just an online website where you upload your paper. That's it. Done. They maintain it well. They provide citation and all this stuff as if it is real paper, but nobody will review it for you. They might give you some logistics, something. They might reject it and ask you to fix some other stuff and then upload again. Okay, but they don't give you any insight about the content. In 3 days, they will send you a password where you can modify, be author of the paper, and so on. Okay, once you upload the PDF. There are a lot of very impactful papers was just uploaded to archive and done. They don't publish in a conference, in a journal, nothing. They don't even pay publication fee for it. And they still get thousands of citation for the paper, people using it, people trusting it, okay? So going to conference or journal, it's not really important. It's not the thing. It's very nice, yeah, but you will suffer. Sometimes you pay, you will go for the visa, you might get rejected for the visa, you need to travel, you need to spend days, and so on, okay? I don't encourage you to just stop at here, but I really encourage you to start from there. Whenever you get your paper ready, put it in archive right away. It will give you benefits that you are the first to do that idea, so you are not getting scooped. Scooped mean someone else do the exact same idea and publish it before you. You were doing it the first, right? However, in the review process, it took like 6 months, 1 year to review it or put it online as accepted, right? During that 1 year, someone else just put it in archive and he scooped you, right? Yes, please.
There are some restrictions that work should not be published.
Excellent point. There is an issue sometimes with the copyright, but most of the top journals, they have no issue with that. They will tell you clearly that you could put it on archive services. You don't have issue with that. The second thing is the blind review. There is part of the conferences it's optional, it's up to you. Do you want your paper to be blind reviewed or regular reviewed? Blind reviewed means whoever is going to review your paper, he does not know what is your institution, your affiliation, your country, your name, and so on, okay? But most of the time, this doesn't make sense because if he searches for the title, he might find it somewhere that you already published similar paper or poster, right? Because normally people, once they arrive to the publication point, they went through a lot of things. They publish the abstract in some conferences, they present a poster, they provide the talk, right, somewhere else, and then they publish the full paper. That's why it's still optional if you want to go for the blind process. If you go for the blind process, they require you to not publish to an archive, okay? Because your identity will be revealed. So what is the point of blind review? There are some issues like that, but most of top conferences, top journals, they encourage you to put it in archive, okay? All right, now with the important, another practical aspect, how you prepare your talk, okay, or presentation. With 4 steps, clear algorithm. First, you check your presentation date, okay? Once you know the date, please prepare well in advance so that you give me more time to give you feedback and you get more time to prepare, okay? If it is a month apart, please start this week to prepare, okay? Start early. If you start early, you get the chance that you work more on the presentation before the final exam, the projects, and so on. Once you already know that, you set the date, you need to study your paper. So there are 3 C's of reading: careful reading, critical reading, and creatively reading the paper. Okay? If you follow the 3 C's, along with the previous thing that we were mentioning in the talk, and everything coming after this, which is really important about the slide itself, how you prepare the slide, I guarantee you a very successful presentation, and you will get very good grade. Of course, the grade here is not our goal. We're not looking for that. We are looking for knowledge and skill set. This is what I promise you in the first lecture. I promise you to build your knowledge in computer architecture and to gain a good skill set that you can use elsewhere. You can try examples by hand. You can download the tool, run it. That's optional, up to you. How much in depth you go in the paper analysis, how much will be appreciated. Okay? If the tool is available, run it. Why not? Normally, they provide you the data, what you expect as output and everything, instruction in GitHub and all this stuff, right? You just need to follow some instruction and run. That's it. Consult with mentors. Mentors, basically me and the TA and anyone else interested in attending your talk as a preparation or the final presentation, okay? Create the draft presentation that hopefully before the preparation, please don't come to the preparation date without slides, okay? Don't just say, okay, I'm going to present about this and this, I have prepared this and that. Don't do that. Please prepare a draft. It might not necessarily be like fully complete, fully beautified with all the colors, the font, the styles, the motion, the slide number, and all this stuff. That's why I'm here, to give you a lot of comments and do's, right? But at least the core idea or the flow of your presentation is still there. This is my story. Even if the picture is not nicely drawn with low quality, that's fine. It's not final. We know that. It's a draft. But at least you have all the division or the motion between the slides, you have it there, okay? Meet advisor, get feedback, fix all the comments I give you. Normally you present for 1 hour, and I spend another 1 hour or so with you, giving you comments on every single slide in your talk, okay? Either we agree on another presentation day, preparation day, okay? Or you just go for the final presentation directly. This is what I expect from your side. I expect at least 20 minutes presenting the paper as if you are the first author. Not a third party, but as if you are the first author, okay? 20 minutes on the problem, the goal, the key idea, the novelty, the mechanism, implementation, major results, and conclusion of the paper, okay? These are the things that we discussed already. However, I expect also where your contribution lied in this very important part, which is about 15 minutes of critiques. Critiques is put yourself in a foot of expert, and now you're attacking that paper. If it's providing something nice, okay, that's great. If it is providing something negative, that is also something great, because this is where a space for improvement happening for next researcher. And you need to highlight both, not only the problem, but also the advantages and the disadvantages, okay? Please pay attention to that. I give you a lot of hints on how you can generate these insights or the problem or the critiques, right? By just following the chain of sources, you can find a lot of problems. By going to the baseline and go to their original papers and find out where they perform best, where they perform bad, you could find a lot of troubles over there, okay? You could also go to the paper who cite the paper you are reviewing. So we talk about the paper you are reviewing, they have a reference list, right? And you go to that paper. Now we want to do the opposite. Now you have the paper that you are reviewing. Whoever cite that paper, I want to go and check what they say negatively about this work. This is how you generate more critiques, okay? Of course, you might come up with a new idea, and I have nice experience with the student in Switzerland. They were analyzing the paper, they were successfully generating ideas, and then they continue doing masters with that. Okay, this is how it starts. Finally, you'll have 15 minutes of discussion. You don't have control over that. Of course, the student might not ask you any question at all, and then this is not your fault, but you might be blamed for that because you don't have question starter, what we call starter question or question starter, where you really encourage people to ask you questions. They might get bored while you are presenting, right, or sleepy, okay? But you could really encourage them to ask. You could open the door for them. You could say, okay, can you imagine this? Can you look at this? What do you think about that? What went wrong? You could highlight exactly what you want them to say. This way, you encourage them to speak something, and then you open for another question, someone else asks you, and so on. It goes like that. So you really have to encourage the audience to start the question. You have to prepare yourself as a presenter to prepare some question and ask the audience for those. Although this is not your goal. When you go to a conference, you cannot ask the audience because you barely see them. Normally in conference setup, there's thousands of those people attending, right? And the light blurring in your eyes. So you don't see them basically. So you cannot ask them question, but you expect to get some questions. And it might be very good to prepare yourself how you could answer this question is to ask yourself a question. Oh, people might ask me about this. Let me prepare an answer for that. People might ask me about this and that and that. Let me prepare, write it down before I forget. All right, so here's a more jump into the slides format, okay? How you format your presentation. The first thing, as usual, you should have a title, the authors, and the venue where the paper you are reviewing was presented or published. This should be clear from the first slide. You should have the title of the paper, the author of the paper. If the affiliation is something to pay attention to it, please mention it, like all of them from Google, all of them from Microsoft, from Facebook, and so on. Please highlight that. Please mention your name on the first slide as well, okay? And don't forget the venue. Venue is very important. It will give some impression that, oh, this paper was published in something good, okay? Next slide directly is a summary, or what we call executive summary. Executive summary means in one slide, you give me the entire story. In one slide, you talk about the entire paper. Same as the story, in 1 minute, you describe your research, okay? It's not a conclusion of the paper. It's an executive summary. And now we will see what is it. Let's skip, we will see an example. Once you finish that single slide, and also you give me the story after that single slide, you start introducing your talk, right? You jump from one to another, all the things that we mentioned, the implementation, the idea, the related work, and so on. We go with the critiques, which is the strength, weaknesses, and the ideas that you build on top of it, and the takeaway. So basically, this is the paper itself. This is your critique or everything you contribute. And this is the takeaway and the brainstorm and discussion. Now let's see a good example of the first slide. Of course, you can follow my style on how I have my first slide. Please pay attention to the detail, the name in bold. You have some logos representing the affiliation. You have the venue where you are presenting this, what date, what semester. You have the title clearly differentiated from everything else. This is very important. And you have clear colors in the slide. You don't use too much color, but you know why you are using this color. You have other example. This is from other students who were presenting in this course in Switzerland. So you can see some examples. You can follow them. You can add your picture. You can follow whatever style you have. However, please avoid this. Please avoid this. This one. Please avoid it. I saw a lot of examples from this. Please try to avoid it. What is the problem here? I don't want to go back home with all the chocolate with me. So please participate. Yes? You cannot differentiate which is which, right? What else? Yes?
There's usually the preface that tells the audience what is going to be discussed and answered. Not going to tell.
What do I have here? Okay.
Oh,
What else? Not intuitive. Okay. Font is very small. As he said, we cannot differentiate which is which. Author name. Excellent. What else? Oh, we have this is the author, this is the presenter, right? But we don't have the venue. Where was the paper presented? Excellent. What course you are presenting for, right? And the date of the presentation, when did you present it, and so on, right? Affiliations of the author, if it is important, you highlight. If not, sometimes, because sometimes it's a really long list of author. If you include in the first slide, it will be boring. It will be really crowded. It's not centered. There are a lot of white space around it. How about this? What's wrong?
Is the authors required for the presentation?
What do you mean?
Like for the presentation, if it is like the authors required.
Yes, you have to include the author list who proposed the paper, because it's not yours, right? You are presenting as if you are the first author, but it's not yours. So it's really important to mention that in the first slide. But what went wrong in this? Dramatic, right? Excellent. You're the big guy. Don't use animation first slide. How about this? What went wrong? Too much drama, right? Don't do that. I saw a lot of people spinning the wheel. Don't do that. All right. So hopefully you'll be clear on the first slide. Please pay attention. Please take care of the first slide. It's really important. It will represent you. Okay? It's not just presentation for the course and that's it. Believe me, if you beautify one style, you could use it for the entire life. And this is what I'm doing myself. I use one template for everything. Just from time to time, I might change the color of that box. You saw some logos, some stuff, and that's it. Everything, even the font here, I set it myself. This font type, the size, and the font over here, the signature, and so on. And then you can use it for whatever. So you just need to pay attention, a little bit of effort to one template, and then done. Save it somewhere. Put in your Google Drive. Put in your email. Download, fill with the stuff every time, and that's it. All right. For the summary, which we call executive summary, this is one slide presenting the entire paper. This is really important, and you have to follow it precisely. You have to start for the motivation, which is the story. Remember this circle. This is the motivation until you jump to the particular problem that you need to solve. Now, describe the problem clearly in one line. What is the goal of this work to address this problem, apparently? And then, what is the evaluation result that they got and how important? What is the impact? Don't list the result. Again, this slide, the purpose of this slide is not a summary of the paper. It's just to highlight whatever important things that audience should pay attention to. From the first 1 minute, I could say, oh, this talk is not interesting. I'm leaving to another room, because normally in most of these conferences, you'll see tracks. I told you about the tracks, right? Each track specified or dedicated for certain topic. Just processing in memory, just domain-specific accelerators. That's it. And all of them is parallel session. All of them exact same time, happening in the conference venue. So we have like 10 rooms. All of them have talks. So which one to choose? All of them are interesting. Just attend the first minute. Oh, okay, bye-bye. Go to the next room, and so on. Okay? This is another example you could follow. Problem, goal, contribution. Again, the contribution here is just not a list of your results. It's an impact of those results, how important these. Or they provide 100x of speed up compared to this and this. Okay? You could provide a conclusion at the end that still, even with that much of acceleration, we are still very far from the goal. So we leave it as open problem. And then the strength, weaknesses. I don't have much to say except whatever I show you how to generate all these weaknesses and the strength. But you have a lot of videos online so you can follow. We have a set of questions. If you ask yourself after you read the paper, it means you can successfully at least digest the entire material of the paper. If you ask yourself this question and you could answer them, then it's clear that you already digest the paper. What is the problem? Why is it hard? How is it solved today? Or limitation of solving it today? What is the new technical idea? Why can we succeed now but not before? And what is the cost? Could be computationally, could be money, could be time, could be effort, whatever that we need to pay to succeed in solving that problem. What is the impact if successful? Who cares? Impact normally that we already solved the problem, right? Or we change the way we are solving it. We propose totally new direction to solving it. Writing is very important. Please read this slide. I already mentioned most of the things here, especially the question side here. Answer expected question, especially on why, how, which, and who. Whatever sentence you mention in your presentation, try to ask yourself these 4 questions. They did it this way. Why? Oh, I don't know. I didn't read it. Oh, I forgot. Don't do that. Just ask yourself why you do this. Okay. Here, I think in 10 minutes, we will be done in about 3-4 slides we have. But it is really important on do's and don'ts. Okay. The first one, when doing a paper review and analyze, be very critical. Please don't be superficial. Don't touch the surface of the paper. Always think about better ways of solving the problem. They propose this way. What are the other alternatives? You can tell the audience, they propose to do this, but be careful. As I said in the previous slide, the related work, there were much better direction to solve the problem. I don't know why the author decided to choose that direction. Okay, you could do that like that. Question the problem. Always ask yourself the 4 questions: why, who, how, right? Read background papers, check the reference list. This is how things progress in science engineering, as we mentioned. Be critical thinking and analysis. There are a lot of videos on good presentation online in YouTube. Please check some of them. This is very important, at least for self-growth. Each slide, prepare that it will take about 1 to 2 minutes. Each slide, 1 to 2 minutes. So if I ask you to present for 30 minutes, it means at most you will have 60 slides. Okay? Attending a seminar is not a replacement of reading paper. I saw a lot of your colleague, what he does when he prepares presentation, copy from the paper, paste in the presentation. That's it. Copy full sentences, put it there. By the end of the day, you'll see a lot of text on the slide. Presentation is not a paper. Paper is not a presentation. So the goal here is to present material in visually appealing way. Okay? If you have very long sentence, please summarize it. Please have it in 4 words, 5 words at most, in 1 line in the presentation. Okay? You could remove the verbs. You could remove the nouns. There are a lot of things that you don't need. You don't need to provide complete sentence. You don't to say he is the. Just say whatever was proposing. The fastest, the best performing, the lowest energy consumed by this. That's it, done. Okay? Organized slide to emphasize the big picture. Always go from the bigger picture to the point directly, but you never do the opposite. Don't jump directly to the problem, then give me the story. Always give me the full perspective, the full picture, then jump into the detail. And this is important when you explain figures. You'll see a lot of figures, they have a lot of boxes. Don't jump to one of the boxes. No, tell me what is the picture about. This figure describing the workflow for this method, and it has 4 steps. These steps related to improving the performance. The first one, if you look at this box, you will see this and this. The second one is this and this. Okay, I jump from the bigger picture into the smaller one, narrow down all the way to the exact point that I'm going to explain. Fill in details verbally or refer to your paper. What does it mean? Again, the paper is not a presentation. Presentation is not a paper. Please remember that. What does it mean? It means when you have a lot of information in the paper, don't try to fit it in one slide. You could get the most important thing and say, if you check figure 6 in the paper, you will see a lot of details. Please refer to that for more information. Okay? But make sure this is not important information that you are referring to. If it is important, please include it in the slides. Make sure all slides have a slide number. This is really important. Really important to have a slide number. Except the first, of course. First slide, no slide number. How to give a bad talk, how to give a bad presentation, how to get a bad job, how to be a bad person. Okay? Looks like a very different way of looking at the problem. Normally, we go with the way how we look better, right? But if you know how to look bad and you avoid that, you're already better shape, right? This is another way how you tackle the problem. Please read this PDF. This is from someone who is well known in computer architecture, David Patterson, who wrote the book that we are studying this course. Okay? One more, please attend his talk. This is a very famous talk 9 years ago and still relevant. He is really mentioning what mistake people do at the interview, at the job, at the presentation, at the talk, at the research paper. And once you check, this is 9 years ago and still very relevant. People are still doing these mistakes. Please attend it. Please watch it. I think it's about 1 hour or so. You could have it as a podcast while you are running, just listen and so on. But sometimes it's important to look at the screen. Okay? He shows really a lot of jokes, a lot of nice things. Okay? Don't try to rehash the paper. Don't try to rehash the paper. Your value is in analysis and critiques. What does it mean? Rehash, you put old ideas, material into a new form without significant change. What does it mean? You copy paste from the paper and that's it. You don't provide context. You don't provide your thoughts. You don't link this sentence or contribution with the previous contribution. Once you move between the slides, you don't say, in a minute, I'm going to explain this. If you don't say that, it means you don't know your flow. Okay? It's important before you introduce something, you introduce the audience to that idea. Next, I'm going to present about that. In a second, I'm going to tell you why. Okay? In 5 slides or so, I'm going to tell you how they achieve that. Please try to add a lot of these sentences between the slides. Don't write them down, okay? But prepare them in your head. Don't paste full text, please. I need to emphasize this maybe 100 times. I saw it many times, even in PhD defense. Please don't do that. Don't use complete sentences. Again, the slides, it's not the place for that. Don't add the is and he and she and we and thee. Don't do that, okay? Just use short, clear bullet point. Don't overload with jargon. Make sure every sentence you include has a purpose. What is more important after you include the sentence, make sure you use colors. Make sure you highlight the important word. It happened with me personally. When I start presenting, I look at the slide, I see it's blurry. It happened with many presenters. You know why? It's not like you have a problem with eyes. It's with the stress. When you present for 1,000 people for the first time, you know no one in the class, or you know one in the venue. This is your first time to be in this hall, for example. It happened to you also. Sitting in the seat in the back, it's very easy attending someone presenting, right? Once you will be here, you will feel it, okay? When you highlight the important word, it will help you to stay focused, okay? I cannot read the entire sentence, but once I saw just one pointer, don't paste full text. Oh, I remember the entire sentence. I don't need to look at the screen. Just I saw that red thing, and then I continue with the audience. And that is the best way how you present. Don't set your back to the audience. That's very bad. Don't try to read the slides. Don't just present numbers. Make sure you give insight. What does this number mean? Okay, this is 50 watts. So what? Is it high? Is it low? Is it medium? Less than the previous one? This is like 100 seconds it takes to execute this program. I don't know. This is 100 good, bad? Is it something need to be improved? Please give me some context. Don't just show numbers. Don't superficially cover all result. Means if you have a table of result, don't show the table. This is not a good way of showing the results. You show the table and then highlight where I should focus. There are a lot of cells. Highlight in red box. Tell me this is where you should look at it. Can you tell me why this is lower than the rest? Why it's higher? Is it outlier? Did they do something best? Okay, you may not highlight the entire row because it's not always best in everything. So you might highlight a box here, a box there, a box there. And this is how you build the insight with the results. This is how you highlight some story that you might explain in the next slide. Don't show cluttered figures. What does it mean? One more chocolate. What does it mean? Blurry picture. Yeah, don't do that. Too much information. You're a bit closer. Copy paste, especially if the figure is no, not small. If small, no problem. If the figure is really big, here we have 2 chocolate. If there is a really big picture or a big diagram, a big figure, a big movie, a big whatever, don't have it as one shot. Please don't. That will be abrupt, something sudden. It will struck the audience and they don't know where to look. Okay, where to start? Where's step 1? Where's step 2? Where's step 3? If you have a big picture, it's good to fit it in one slide, no text at all, just the whole picture and that's it. But then cut it into pieces and show it gradually, one piece by one piece. You can cut it yourself. You can make a lot of copies and then crop each picture to highlight specific portion and show it animated gradually, okay? Tell them, look at this, look at that, look at this. Now let's see this. Now let's see the next step, okay? This is the best way of how you do the figure. And it might be better, you take it to the next level and you redesign, redraw that figure yourself, okay? This is how I do it myself. This is how I maintain high quality slides. All my slides, none of them blurry, even the picture. I try all the best to build myself all the figures with the boxes, with the arrows, with the text, with the animation. This way you maintain high quality and you can control everything. You can not just animate portion of the picture, but you can animate the niches, the detail, the fine grain, the arrows inside the boxes, you can animate them. And this is where you take it to the next level. Don't skip critiques. Hopefully I emphasized this too many times. Don't read slide word for word. Okay, this is extremely important. Don't just look and read. That's why we highlight words. Remember this rule. It's up to you. You can highlight it in red, blue, green, whatever colors, but be careful for color blind people. Okay, don't use the green and the red. If you use red, use it only red. With the black, it's okay, because the red in color blind people will be gray. So to see gray and black, sometimes fine at least, okay? But don't mix with green, for example. Then both of them will be gray, then you are not highlighting differences. How to handle a question. Hopefully this is the last slide. Always try to repeat the same question you receive, because people asking question from that side, people on that side, they didn't hear it. So try to repeat it. They ask you, you understand it, you could rephrase it in your way, or ask them, was that your question? You repeat it and ask them, was that your question? Always be respectful. Even if they ask silly, let's say stupid question, don't laugh, okay? Because you are expert in the paper. You spend like 3 months just reading that paper. Don't expect others to be expert in the field. They might ask you something you didn't understand it correctly. So tell them, was this your question? If so, yeah, tell them, okay, I don't think that was correct. They handle it in a different way. We could discuss it later on. Or you could provide an answer. Avoid long one-on-one discussion. What does it mean? He asked me a question, I answer. He sent a follow-up question, I answer. He sent again another question, I keep answering, right? Avoid that. If he's really interested that much, tell him, hey, I'll see you after the talk. That's it, done. You could spend 1 hour after that. Go to the cafe, go for lunch, that's fine, okay? Because the else, they don't know necessarily what you are talking about, okay? Try to avoid that. Double check if you answered the question. Ask them back, did I answer your question? If you cannot answer a question, there is a very nice way to skip that, to run away from that. Tell them, I hadn't thought of that before. Very professional, very short. Or you could tell them, I don't know. That will be better if you tell them, oh, that was a great question, but I never thought about it. Let me think about it and get back to you. Can you send me an email? Make sure you provide your email in the first slide, okay? Make sure you answer that email as well. All right, I think I'm done with a lot of don'ts and do's and so on. Hopefully you pay attention to them. Please revisit them. I try to present them now before you decide on the paper, so you already have enough time to digest the material. The presentation of the previous lecture, it's already online on YouTube. I think it will be available on tomorrow, 10 a.m. probably, okay? It's already online. If you need more information, please ask ChatGPT for whatever question you might find. I provide you one prompt, but you could come up with too many ways where you can find a lot of recommendation on how you prepare your slides. There are a lot of intuitive things, like very trivial on the colors, the background, what font size, what font type, and so on. I believe all of you PhD students, you could do that, okay? I will emphasize this once we decide on the paper. 20, 60, 20, based on our discussion from last time. So I fixed the grading over here. It's no longer 20 and 80. It's 20, 60, 20. Hopefully this is for your good. If you come prepared for the preparation meeting, you will get the 20 full directly. If you did well in the presentation, 60, the attendance and participation 20, okay? Hopefully I break it down with exact questions so you know the grading criteria that I will be using, okay? If you have any concern, please send me email, and thank you so much. Hi. Oh, you are one of these guys? I don't know what should I do. You see, the class is already full. This is your last semester, you said?
Yeah.
Okay. Why you are late? I'll do my best to check today.
Yeah.
I have, I think, 3 cases. He sent me a link where I can send a request. I didn't know that before. But you might find a problem with the chairs. You might want to bring your own chair.
Downstairs.
Because this is 45 student, 45 chairs. I asked my TA to not attend. Otherwise, he will be standing all the time.
We can get one.
Yes, please. I will see, but that's not a promise of acceptance because I will send a request. I don't know if it will be approved or not.
Yeah.
Okay. I'll try to do it today. I'll not to send for everyone. There are 10 students ask me to join the class. I cannot do that for all of them. But if it is really the last semester and you have no other courses, you already take all the advanced courses, I'm happy to help. Okay, okay, okay. Nice meeting you. Thanks a lot, Sananda. Hey, good to see you again.
I know. So one of my, you remember Dose I did it?
Yes, yes, I got her email.
Yeah,
I'll reply to her.
Okay,
No worries.
She asked me to come to the hospital.
Will she attend from hospital?
She's from home. She's like going back
Okay.
between hospital and like doctor's visits. So she told me she's like gonna try, for the meeting preparation to come for that, and if she needs to come, for the presentation here, she'll definitely try to.
How will she come with the old devices connected?
I don't know. Hopefully by that point they're like still like diagnosing, so it's like hard for her to get an idea of what to do. But hopefully if it's in October, hopefully it'll be a better position.
She's very strong.
Yeah.
She's
So
very
she told
strong.
me, I can't come. Can you and Jake come? And I'm like, yeah, for sure. But she said like she can attend virtually.
Yeah, definitely. I'm happy to accommodate that. Probably I can send her a Zoom link.
Okay,
She can
yeah.
join from hospital,
Yeah.
from home.
She tried the WebEx, but it wasn't working, so she asked me.
No WebEx, no
Yeah, okay.
WebEx. I will be using Zoom.
Okay.
There's one student, I'm not sure, I forgot to check. There's one guy who will attend from Pakistan over Zoom. So yeah, please remind me, all of you, remind me to accept the people who over join Zoom.
Okay, I'll do that.
Sometimes I need to manually accept one by one.
Okay.
Yeah, just make sure I accept her
Okay.
before the class, and that should be fine. No worries.
Thank you.
Yeah, thanks a lot. Good to see you again.
Because I was waitlisted, I wasn't able to go, but thankfully I got.
I have no control over wait list. I cannot move people from here and there. I think the department has to do it.
Yeah, thankfully I got it. Nice to meet you, Professor.
Yeah, really good to see you again. Thanks a lot. Hey, you are one of the students want to join? This is also last semester.
Yeah.
What's your name?
Hari Surya.
Oh, okay. Yeah, I remember.
So today I met Jamie and talked to him and so he told me there's task force and you can send me the link. So
Yeah, of course I can send the request, but the room is full.
yeah, well, if one of my friend is waiting for that.
Oh, really?
Yeah.
Step out and then you
Yeah.
take in. Please send me a mail again now because I'm going to take care of it tonight. Okay, I'll check the list again. 10 students. I'll see which one in last semester. I'll probably accept only those. Okay. Yeah, but please remind me that there is might one student step out and then you take place. I cannot also swap. I cannot control anything in the student registration. Okay, so no guarantee that you could be swapped. He might be out. Someone else might be on the wait list. I don't know. Okay. Yeah. All right.
I'm working under a department, so due to some HR issues, my waiver applying is getting delayed. So I'm just
Oh.
informing you that just in case if my class drops,
Okay. Okay.
just inform you.
All right. Yeah. Thanks for informing me. Yeah.
Nikita.
Nikita. Okay. Thanks meeting. Thanks for informing me. And when do you know exactly?
Getting
I think tomorrow will be last day. Yeah, I think it's good to accept some of those, maybe 3 or 4 students. If you drop,
actually the department has given my name to not drop list. like my courses will not.
Oh,
get
okay,
off,
okay,
just inform me
okay,
first.
okay, got it. All right, thanks a lot, Nikki. Naim, how's it going? Yes, we should meet for your project, you and Sapar. I'll let you know the time or over Zoom if in worst case.
Yeah.
We need to submit the grant proposal.
Then I can know by tomorrow morning.
I'll let you know tonight. Okay? Yeah. Oh yeah. Have safe trip. Hi.
Send an email, right? for
No,
the-
nobody could register. They cannot register. The registration already full. It's already closed. What we do, special cases, case by case, we send special requests to the registration team to register these.
But will you send already the registered student send the email to choose the list of papers, right?
Oh, okay. Yeah.
So after you send someone register, will they also get the email? Or you just forward that?
I don't think so. I don't think there is a new student register after we send the list.